All right, ladies and gentlemen, hi, how we doing? Here's the plan for today. I want to go through some of these notes. Know that it's kind of a, I don't want to say a longer section, but there's a lot of slides here. Just some review over quadratic functions and what they look like. That's all of chapter 5. Chapter 5 is all quadratics. We spend a good amount of time in chapter 5. We'll be here till Thanksgiving and even then some. We're gonna be sitting in this for a while. I just want to let you guys know I probably will not have the tests graded probably over the weekend. My plan is to try to come into school to get them on Saturday, but probably I don't know. We'll see. I don't know. We'll see. It depends on how I'm feeling. Okay, so chapter 5 is all about quadratics. Remember, quadratics, you did study quadratics in Algebra 1. It's anything with a U shape, right? Or anything with an x squared up top there, right? That's what makes a quadratic a quadratic, okay? I'm probably getting ahead of myself. It's probably going to say it right here. But that's what this entire chapter is about. Now, today we're going to do section 5.1. On Monday, we are in this weird limbo where I will see you guys, most of you guys, for all of the time that we would normally have Honors Algebra 2. But the thing is, not all classes will be doing it. We'll have, the full time in Honors Algebra 2 on Monday because of Veterans Day. And I'm going to be missing some of my kids that are in reflections Monday morning on Veterans Day. So it really is kind of a crapshoot if I'm going to see you or not. So here's what we're going to do on Monday. I'm going to teach you this lesson now. On Monday, I'm going to go over this homework assignment. I'll answer any questions that we have. I'll even go back through the video if you have any questions on anything that I've said in the video. Maybe I've screwed something up royally and I need to go back and teach it again. Hopefully that's not the case, but I don't know. So we're going to go through everything that we need to go through in this video, or any questions that you may have. But we're really kind of in this holding pattern where we can't really learn anything new on Monday because we'd be leaving people behind and without a day to catch up again. So if I'm going to see you on Monday, because Veterans Day starts like 10, 15 minutes before the end of the period on first period. But 7th period people, I will see you guys. I will see you guys the full time. So we'll just hang out, go over some homework. Maybe I'll go over the test or something if I've got it graded. If not, whatever. So it really kind of depends. Maybe we'll just hang. Maybe we'll just chat about life, chat about anything, Okay. All right, so let's go through it. Why don't we get out our notebooks and just start in here. Again, the nice thing about all these videos is you can pause and you can do it at a relaxed pace. You can do these notes at your leisure, because we were, this would be leisure time. All right, section 5.1, using transformation to graph quadratic function. So what the heck is a quadratic function? Well, a quadratic function is a function that can be written in the form f of x is equal to a times x minus h squared plus k. That is a very important formula, actually. Okay, yeah, never mind. That has a special name to it too. Well, I think we'll talk about that a little bit later on. In a quadratic function, the variable is always squared. I think I talked about that at the beginning there. See, look, there it is there, x squared. The table shows the linear and quadratic parent functions. Okay, so let's take a look at linear and quadratic, how they relate to one another. These are just the parent functions. Again, if you ever need to pause to write anything down, please, by all means, go for it. So here are the linear and quadratic parent functions. Notice the x values are staying the same, but the y values are different, right? The y values, I'm just going up at a constant rate for my y values, but here, look, 4, 1, 0, 1, 4, I'm increasing, I'm going up by 1, up by 3, right? Down by 3, down by 1, up by 1, up by 3, right? So it is not a constant it's not a constant change, not a constant rate of change. A constant rate of change would be a linear function. It's not constant here, so it's quadratic, okay? So here's a quadratic, it looks like a parabola, okay? So we can also graph quadratic functions by applying the transformations. Hey, look, our good friends, the transformations, they're back again. To the parent function f of x is equal to x squared. Guys, I want to reinforce this. I think I've said it before, but I want to try to say it again. Any quadratic function is a transformation on the parent. Anything. Every single quadratic function that we will do in this entire chapter is just some sort of transformation on this parent. Some sort of. So let's talk about the transformations. All right, let's talk about our two most basic ones. We've got the horizontal translation and the vertical translation. I'll move these down here. Okay, so take a look here. A horizontal shift. Okay. Take a look here. That's what we should be writing down. Everything else is the same. But this is how it applies to quadratics. Same thing here. You know, think about what do we know is the transformation rule for horizontal translation? It would take f of x and map it to f of x minus h. So if I'm thinking about just the original parent function, I'm just going to take x minus h and put it in for the input. I'm going to remove x out of x squared and in its place write x minus h squared. Right? Now that implies things that we'll have to like FOIL that out and everything like that later on, but not right now. We're just going to leave it right there for right now. Vertical shift. Okay, that means, you know, think about it. It was like f of x is going to transform into f of x plus k, right? Plus k. So that plus k is sitting on the outside. Look, plus k is sitting on the outside there. So these rules that we have for transformations, they're just going to be the same rules. Just how do we apply it to quadratics? Okay, take a look here. Describe the transformations and then graph each function. So this is going to tell us something and this is going to tell us something. Remember, anything horizontal, it's the opposite of what you think it's going to do, and it's going to be inside some parentheses. So take a look. This is inside the parentheses. It's got to be left or right. Okay, I see a minus 2. I'm thinking left, but no, no, no. It's opposite. Right 2. Here, straight up. Up 4. Right 2, up 4. Now, what do we actually transform? We actually transform going right 2, up 4, my vertex. That's a really important point there. Right 2, up 4 with my vertex, okay? And that parabola is based off of that. Now, oh gosh, I'm very sorry. I'm really horrible at drawing parabolas with this tablet. Please excuse me, please excuse me. But again, right now it's just a sketch, okay? We're not really getting into exactly what it's looking like right now, but it's just a sketch. Where does the parabola move to? Remember, this is the rigid transformation where it's going to go right 2, up 4. It's going to have that same curve to it, just going to be shifted up and to the right, okay? Same thing here. What's happening here? Pause and think about it. What is happening here? 2 things I see. Here and here. Okay, this guy is a left 2, you know, opposite, counterintuitive of what you think. I see a plus. I think it's going to go right. Oh, wait, it's inside. Go left. Down. Okay, left 2, down 3. So I'm going to take this important point here. Left 2, down 3. There's my new vertex. I'm going to say I'm sorry before I even start graphing. I'll try to go faster. Did that help? What? No, it did not help. I'm really sorry about that. Again, it's just a sketch. People, just a sketch. So let's talk about reflections. Okay, the reflections. Reflections are just, you know, the negatives, right? Negative outside, reflection across the y-axis, changing the x. Inside, so f of x is going to map to f of negative x. So what does that imply here? Oh, nothing. Not in terms of the parent, right? It's actually, if I reflect this across the y-axis, nothing, you're not going to see a difference. Why? Because when I square the negative, it's going to turn back positive. Interesting. But you will see a difference when I put the negative outside. Negative outside will reflect it downward. Okay. Let's take a look here at our stretches and compressions. Ooh, I better get these out of the way. Move, please. Go down. So long. Farewell. Okay, so the horizontal stretches and compressions. Remember, the horizontal stretches and compressions, 1 over b is the reciprocal of the value. So if I'm going to stretch it by horizontally stretch it by a factor of 3, that's going to be 1/3 inside parentheses x, and that's squared, right? If I'm going to vertically stretch it by a factor of 4, that it would be 4 times f of x, so 4 times x squared, okay? All right, so those are our stretches and compression. Let's try some. Describe the transformation and graph the function. All right, so 3x squared. So, ooh, this is happening inside. So that means that it's going to be a horizontal something. Horizontal. Now, remember, it's the reciprocal of the value of that. So horizontal something by 1/3. Okay, if it's a 1/3, that's a compression. Okay, horizontal compression by 1/3. So that means all my x values are going to get compressed by 1/3. So my x value here of 1 is going to get compressed by 1/3. Oh, I should have done red or something. Here, going to get compressed by 1/3. Going to get compressed by 1/3. Going to get compressed by 1/3. So it's like this. Whoa! Again, oh my gosh, I'm so embarrassed of that. Oh gosh, I'm really so sorry. Okay. Oh, I know what I'll do. I'm totally going to graph it in my calculator for this next one. All right, so we got two things going on, this negative and this 1/2. Okay, what does the negative do? Get out of my way. Get out of my way. What does this negative do? That negative on the outside flips it downward. What does the 1/2 do? Well, since it's on the outside, it's going to vertically compress it. Compress it. Vertical compression by 1/2, and then flip downward. So reflection over the x-axis. Okay, so it reflects over the x-axis and then vertical compression. So it's going to make it wider. Hey, that one's not so bad. Okay, yeah, it is so bad. Okay, so let's graph it in our calculator just to see. Let's go into our y equals and clear out anything that's there. And let's type in negative 0.5 x squared, and then our original just parent function x squared. Okay, I'm going to zoom 6. There's my new. Oh gosh, it is not that wide. Wow, I sucked here. Okay, there we go. I'm just going to, you saw nothing, you saw nothing, you saw nothing. Okay. All right, let's keep it rolling. Okay, I said it'd come back again. This is called vertex form. Everybody pause your videos and write this down. This is huge. This is huge. This is huge. Write this down. Okay, I don't need to pause. I don't need to wait because you're pausing. Okay, so what do all these things mean? A is an amount of reflection, or sorry, is an amount of vertical stretch or compression and or reflection across the x-axis. If this guy's negative, reflection across the x-axis. If this guy has a value other than 1, it's going to have been vertically stretched or compressed. H is a move left or right. K is a move up or down. Notice that B is not in here. B is not in there because, well, it messes everything up. We don't really work with a horizontal stretch or compression when it's put in vertex form. You can't really tell it very well. So these are ones that have not been horizontally stretched or compressed. Okay, whoa, get out of there. Now, the cool part about this is that if it's in this form, you can see H and K. What are H and K? It's that vertex. It's that cool point, like this guy. It's that vertex point of a parabola. Okay, if it's been shifted around, H comma K is our vertex point. Okay, okay. See what I did there? Okay. So the parent function x squared is vertically compressed by a factor of 1/3, translated 2 units right and 4 units down to create g. Okay, I can do all of this at the same time if I know a times x minus h squared plus k. See, like that like rolls off my tongue. That's like, it's just like poetry. G of x is equal to, okay, my a value is 1/3. X, no, I go right 2, minus 2. I go 4 down, minus 4. Look at that. How cool. If I graph this in my calculator, trust me, you can if you'd like to. Go ahead, why not? You plug this in your calculator with x squared as at y1, and then plug this guy in as y2. It will do all of these things that I say it does. Okay. Take a look at our last problem here. On Earth, the distance d in meters that a dropped object falls in t seconds is approximated by d of t is equal to 4.9 t squared. On the moon, the corresponding function is d sub m of t is equal to 0.8 t squared. What kind of transformation happened from 4.9 t squared to 0.8 t squared? Okay, what happened here? How do I change the number on the outside? Well, it's either got to be adding or subtracting on the outside or multiplying on the outside. Okay, it did not get added and subtracted, but what did it do? It got multiplied by a fraction. Oh, multiplied by a fraction. That is a vertical compression by a factor of something, right? Well, what could that be? Well, we just take 0.8 divided by, get out of here, 0.8 divided by 4.9. Can that give it to me, or do I have to do 4.9 divided by 0.8? Nope, that's right. Vertical compression by 0.163. By 0.163, okay? What does that mean? What does this transformation mean? That means something is going to fall slower on the moon. Obviously, it's got less gravity, so it's going to fall slower on the moon. This number on the outside is going to tell us how the speed at which things are going to fall. Guys, this is going to come up a lot. We're going to talk a lot about projectile motion and some physics stuff that goes into this. I always talk to Mr. Morkel about this, and we always just like geek out and talk about how cool this is that, we use parabolas and whatnot. Okay, I'm done. But hope we're all having a good day. Check the, I think the sub has the homework assignment for you. Oh, it's probably right by the link that you clicked on to get to here. Do the homework, work together if you'd like to, and I hope we're all having a good day. See ya.